Okay, today I am going to discuss graphical description of uniformly accelerated motion. So first of all, let me differentiate uniform motion and uniformly accelerated motion. So the motions of an object may be uniform motion, or the motions of an object may be uniformly accelerated motion or uniformly decelerated motion, and the motions of an object may be accelerated motion. The motions of an object may be accelerated motion. So in the case of uniform motion, the object is moving at constant velocity. At constant velocity. If the velocity of an object is constant, the accelerations of the body is zero, or there is no acceleration. Acceleration is zero. That's why acceleration is the rate of change of velocity. If there is no change in velocity, there is no acceleration. So to say the motions of an object is uniform motion, the object is moving only at constant velocity. So there is no change in velocity at all. ምንም አይነት velocity change የለም ማለት ነው. In the case of uniformly accelerated motion, the object is moving at constant or uniform acceleration. Uniform acceleration. So in the case of uniformly accelerated motion, the accelerations of the object is uniform or constant. If it is constant, there should be increasing velocity with time linearly. ስለዚህ if there is change in velocity, the object must be accelerated. In the case of uniformly decelerated motion, the same is true here. The object is moving at constant or uniform acceleration. The only difference here is that there is decreasing velocity. Decreasing velocity with respect to time linearly. ስለዚህ the directions of velocity and its acceleration is acting in opposite direction. በተለያየ አቅጣጫ አክት ስለሚያደርጉ acceleration is negative here. Acceleration should be negative here. Acceleration should be what? Positive ይሆናል ማለት ነው. Okay, finally, in the case of accelerated motion, here the accelerations of the object is not constant or uniform. So there is variable acceleration, or there is change in acceleration when an object is moving in a given system. Okay, if it is all about the difference between uniform motion, uniformly accelerated motion, uniformly decelerated motion, and accelerated motion, now let me discuss graphical description of uniformly accelerated motion. Here we have displacement time graph, velocity time graph, and acceleration time graph. ምናልባት አራተኛ distance time graph ብለን ልንጨምር እንችላለን. Okay, in the case of distance time graph, the gradient or the slope of distance time graph is speed. So the speed v the same as distance over time, which is what? The scalar, right? So the graph of distance time graph always goes up and up. It never goes down. That's why there is no what? Negative gradient. ወይም negative slope ስለሌለው it always goes up and up. But in the case of displacement time graph, negative gradient is possible here. That's why the slope or the gradient of displacement time graph is velocity. It is gradient or slope is velocity. ስለዚህ ስሎፓችን ወይም ግራዲያንታችን ቬሎሲቲ ነው የሚሆነው። ስለዚህ እያንዳንዱ ግራፍ ላይ ዲስከስ ስናደርግ የእያንዳንዱ ግራፍ ኔቸር ኢን ተርምስ ኦፍ ቬሎሲቲ ኤክስፕሌን ለማድረግ እንሞክራለን ማለት ነው። ኦኬ ፓርት 1 ላይ ስንመጣ there is what? increasing displacement with respect to time linearly. ስለዚህ displacement ሲጨምር ታይምም ይጨምራል, which means that the motions of an object is uniform motion because velocity is what? constant. ስለዚህ ፍጥነት ኮንስታንት ነው ማለት ነው። ፍጥነት ኮንስታንት ከሆነ there should be change in position። ፓርት 2 ላይ ስንመጣ ፓርት 2 ላይ ስንመጣ the displacement of the object is constant። ምን አለ? displacement is what? constant, which means that there is no change in position. No change in position. So what will happen? Position. So what will happen if there is no change in position? If there is no change in position, the object is the body. Here the body is what? Already at rest. ምንም አይነት እንቅስቃሴ የለም ማለት ነው። No motion. No motion. No motion. ምንም አይነት እንቅስቃሴ የለም ማለት ነው። ምንም አይነት እንቅስቃሴ የለም ማለት ነው። ፓርት 3 ላይ ስንመጣ ደግሞ ምንድን ነው የምናየው? There is what? Decreasing position. The displacement of the body is decreasing with respect to time. Decreasing what? Displacement with respect to time. So the motions of an object is uniform motion. Okay, የመጨረሻውን ፓርት ስናይ ፓርት 4 ላይ ስንመጣ there is what? A parabola, right? ለምን ይመስላችኋል እንደዚህ ፓራቦላ የሆነው? አሁን የኛውን ስናይ the displacement covered by the body is not directly proportional to what? The time taken. የሚፈጅበት ጊዜና ከቨር የሚያደርገው ዲስፕሌስመንት ወይንም ፖዚሽን ፕሮፖርሽናል አይደለም ማለት ነው። which means that there is change in what? Change in velocity. ስለዚህ there is change in velocity. If there is change in velocity, the motions of an object will be uniformly accelerated motion. ምናልባት ከዚህ በኋላ ወደ ታች upward ፓራቦላ እንዳለ ሆኑ downward አይነት እንደዚህ አይነት ግራፍ ካለ ደግሞ the motions of the object is uniformly decelerated motion ብላችሁ በቀላሉ የሁለቱን ልዩነት ማየት ትችላላችሁ ማለት ነው። So this is all about displacement time graph. ቅድም እንዳልኳችሁ distance time graph ላይ the graph never goes down, it always goes up and up. ምክንያቱም negative gradient doesn't make what? Any sense in the case of distance time graph. Displacement time graph ላይ already gradient ወይም ስሎፑ velocity ስለሆነ በቀላሉ እነዚህን ልዩነቶች ልናይ ይችላል ማለት ነው። Let me proceed to the second one, which is velocity time graph. በጣም አሪፍ። እሺ okay, now let me proceed to the second one, which is velocity time graph. In the case of VT graph or velocity time graph, the gradient or the slope of velocity time graph gives acceleration. You know, in the case of distance time graph, its gradient is what? Speed, right? In the case of displacement time graph, its gradient or slope is the same as velocity. So in the case of velocity time graph, its gradient or slope gives acceleration. ስለዚህ እያንዳንዱ ፓርት 1 ላይ ምን አይነት ኔቸር አለው ግራፉ፣ ፓርት 2 ላይ፣ ፓርት 3 ላይ፣ ፓርት 4 ላይ በቅድሙ በተመሳሳይ እናያለን። አሁንም አብራችሁን ቆዩ። So in the case of part 1, here there is what? Increasing velocity with respect to time linearly. ስለዚህ increasing what? velocity. ስለዚህ ፍጥነት linear በሆነ መንገድ increase አድርጓል። If there is change in velocity, the object must be what? Accelerating. The object must be accelerating. So let's see, there is uniform or what? constant acceleration. ለምን ይመስላችኋል እዚህ ጋር constant የሆነው? አሁን to say uniform or constant acceleration, the velocity of the object is changing with respect to time what? Linearly. So if the acceleration of the object is constant or uniform, the motion of an object under this graph is the so-called uniformly what? Uniformly accelerated motion. Uniformly accelerated motion ነው ማለት ነው። In the case of part 1 ላይ ስለዚህ ሞሽኑ uniformly accelerated motion which means acceleration is what? Positive. Acceleration positive ነው። In the case of part 2 ላይ ስንመጣ ደግሞ velocity is what? Constant. ከዚህ እስከዚህ እንደምታዩት velocity አይጨምርም አይቀንስም። velocity constant velocity. Constant velocity. If there is no change in velocity, the object has no acceleration. So acceleration is equals to what? Zero. ምንም አይነት acceleration የለንም. That's why acceleration is the rate of change of velocity. Object to accelerate አረገ ለማለት there should be change in velocity. If there is no change in velocity, the object has no acceleration. ስለዚህ acceleration zero ነው. So the motion of an object is uniform motion. ስለዚህ እዚህኛው ላይ uniform motion ነው. Here uniformly accelerated motion. part 3 ላይ ስንመጣ ደግሞ the velocity of an object is decreasing linearly with time. There is decreasing velocity linearly with time, which means that the object must be accelerating. Already accelerate አድርጓል at constant rate accelerate አድርጓል, but the velocity of the object, the directions of its velocity and acceleration is acting in opposite direction. So we have to make negative acceleration here. Acceleration should be negative. So the motion of an object here is that uniformly decelerated motion. የሁለቱ ልዩነት ይሄ ነው ማለት ነው። part 4 ላይ ስንመጣ ደግሞ there should be what? change in acceleration. Already acceleration constant አይደለም እዚህ ጋር uniformly accelerated ብለን ነበር። እዚህ ጋር uniformly decelerated motion. Here accelerated motion. There is change in acceleration. So the motion of an object is accelerated motion ብለን በቀላሉ ግራፉን መለየት እንችላለን ማለት ነው። ስለዚህ አሁን የሁለቱን ግራፍ ኔቸር ለማየት ብንሞክር እዚህ ጋር ምን ነበረ? ዩኒፎርም ሞሽን። እዚህኛው ላይ ዩኒፎርምሊ አክሰለሬትድ ሞሽን። here no motion but here uniform motion. So the nature of the graph under uniform motion is the same as the nature of the graph under displacement time graph. Displacement time graph የግራፉ ኔቸር ከዚህኛው ጋር ተመሳሳይ ነው። ለምሳሌ the nature of the graph under displacement time graph here ምን ብለን ነበር? ይሄኛው uniform motion አይደል እንዴ? uniform motion under displacement time graph have the same nature with that of what? uniformly accelerated motion under vt graph እያልን የሁለቱን ልዩነት ግራፊካሊ ማነጻጸር እንችላለን ማለት ነው። In addition to this, the area under velocity time graph is numerically the same as distance traveled by the body or displacement. ስለዚህ the area under vt graph is the same as displacement or distance covered by the body. በቀላሉ የነዚህን ኤሪያ ከፋፍልን ከሰራን በኋላ የምናገኘው ውጤት ኒውሜሪካሊ ከማን ጋር እኩል ነው? ከዲስፕሌስመንት ጋር እኩል ነው። ቤዚካሊ ኤሪያ በምንድን ነው የሚለካው? በሜትር ስኩዌር አይደል እንዴ? but distance is what? በሜትር ነው የምንለካው። here አሁን እዚህ ጋር እያልን ያለ ነው ምንድነው? the area under vt graph is numerically the same with that of displacement or distance covered by the body. ስለዚህ በቀላሉ ኤሪያውን ካልኩሌት አድርገን in terms of ሜትር ማስቀመጥ እንችላለን ማለት ነው። so the area under vt graph is the same as distance covered by the body or the displacement of the body. so ይሄንኛውንም ሜትር መጠቀም ትችላላችሁ። okay, now let me discuss the final one which is acceleration time graph. Here, the area under AT graph gives us change in velocity. Already, AT graph area calculate ስናደርግ ማግኘት የምንችለው change in velocity ይሆናል ማለት ነው። So look the graph here. Here, the accelerations of the object is constant. እዚህኛውም ላይ constant ነው፣ እዚህም constant ነው አይደል እንዴ? But here, in this case, the accelerations of the object is what? Above 0, which is what? Positive. Accelerationችን positive ነው. A is positive, but it is what? Constant, which means that the velocity of an object is what? Increasing linearly with time, which means that the motions of an object is uniformly accelerated motion ማለት እንችላለን። ሁለተኛው ላይ ስንመጣ the accelerations of an object is what? Constant, which is below 0. So acceleration is negative, but the velocity of an object is decreasing with respect to time linearly, which means that the motions of an object is uniformly decelerated motion. So what will happen if the acceleration of an object seems like this? እዚህ ጋር ሆነ ማለት acceleration ምን ሆነ? 0 ሆነ ማለት ነው። If there is no acceleration, already graph AT graph ስለሆነ the motions of an object is uniform motion. እዚህኛዋ time axis ላይ ከሆነ ደግሞ the motions of an object is uniform motion under AT graph በቀላሉ ልዩነታቸውን ማየት እንችላለን ማለት ነው። አሁን ደግሞ እስኪ በጥያቄ አብረን እናዳብረው፣ ከኔ ጋር ቆዩ። Okay, here we have an example. The VT graph or velocity time graph for the motions of a motorcycle is given below. So velocity time graph is given. So the initial velocity of the motorcycle is 3 meters per second, and here we have 7 meters per second, and along the time axis there is 2 and 5 here. So what is the acceleration of the motorcycle during the first 2 seconds? በመጀመሪያ 2 ሰከንዶች ሞተርሳይክሉ ምን ያህል አክሰለሬት አድርጓል? You know acceleration is what? Acceleration is the rate of change of velocity. Here we have a velocity or a VT graph. Acceleration is the rate of change of velocity. So for the first 2 seconds, በመጀመሪያው 2 ሰከንዶች final velocity is here, and its initial velocity 3, and final time which is 2, and initial time which is what? 0 ነው ማለት ነው. That's why the required is the accelerations of the motorcycle for the first or during the first 2 seconds. So which is the same as final velocity minus initial velocity over final time minus initial time, which means that for the first 2 seconds final velocity is 7 meters per second minus 3 meters per second over final time which is 2 seconds minus what? 0 second. So the acceleration of the motorcycle for the first 2 seconds is 7 meters per second minus 3, which is 4 meters per second over 2 seconds, which is the same as 2 meters per second square. ስለዚህ በመጀመሪያዎቹ 2 ሰከንዶች 2 ሜትር ፐር ሰከንድ ስኩዌር ይኖረዋል ማለት ነው። አክሰለሬሽን 2 ሜትር ፐር ሰከንድ ስኩዌር አክሰለሬሽኑ ይሆናል። ቢ ላይ ስንመጣ what is the acceleration of the motorcycle during the last 3 seconds? መጨረሻዎቹ 3 ሰከንዶች ላይ ምን ያህል አክሰለሬት አድርጓል? ስለዚህ የመጨረሻዎቹ 3 ሰከንዶች ማለት በዚህ መካከል ማለት ነው። 5 ሲቀነስ 2 ስንት ነው? 3 አይደል እንዴ? የመጨረሻዎቹ 3 ሰከንዶች ላይ ምን ያህል አክሰለሬት አድርጓል ነው። Here between 2 and 5 seconds the velocity of the motorcycle is what? Constant, which is 7 አይደል እንዴ? ስለዚህ velocity እያንዳንዱ ፖይንት ላይ እዚህ ጋር ግራፍ ላይ እንደምታዩት 7 ሜትር ፐር ሰከንድ ነው። So there is no change in velocity. velocity ምን አያደርግም? change አያደርግም። If there is no change in velocity, the accelerations of the object is what? Zero አይደል እንዴ? ምንም አይነት አክሰለሬሽን አይኖረውም። anyhow እስኪ እየሰራን እንየው። acceleration is the same as change in the rate of change of velocity አይደል እንዴ? So final velocity which is 7 meter per second minus initial already for the last 3 seconds ስለተባላችሁ ፋይናሉ 7 ነው። ኢኒሺያሉም 2 ሰከንድ ላይ ስንት ነው? 7 which is 7 meter per second over final time which is 5 second minus 2 second which is the same as for the last 3 second. ስለዚህ acceleration is equals to 7 minus 7 which is 0. 0 over any number which is 0 meter per second square. So there is no acceleration for the last 3 seconds. በመጨረሻዎቹ 3 ሰከንዶች ኦብጀክቱ ወይንም ሞተር ሳይክሉ አክሰለሬት አላረገም ማለት ነው። አክሰለሬት አላረገም ማለት ነው። So let's proceed to see what is the distance traveled during the first 2 seconds. በመጀመሪያዎቹ 2 ሰከንዶች ኦብጀክቱ ምን ያህል ዲስታንስ ከቨር አድርጓል? ምን ያህል ዲስታንስ ከቨር አድርጓል? ቅድም ምን ብለን ነበረ? The area under velocity time graph is numerically the same with that of distance traveled by the body or displacement ብለናል አይደል እንዴ? So the distance traveled by the body distance or displacement is equals to the area under the graph during the first 2 seconds. በመጀመሪያዎቹ 2 ሰከንድ ከቨር ያደረገው ይሄንን ነው አይደል እንዴ? ስለዚህ ኤሪያውን ለመስራት እንዳመቸን እንደዚህ መክፈል እንችላለን። let's say this is a1 and this one is a2 for the whole journey ከተባላችሁ ይሄኛውንም መጨመር ትችላላችሁ ማለት ነው። a3 ትጨምራላችሁ። አሁን የተባልነው ግን for the first 2 seconds ስለሆነ a1 እና a2 ሰርተን ሁለቱን ብቻ መደመር ነው። አጠቃላይ ሙሉ ከተባላችሁ a3 ትደምራላችሁ ወይንም the distance covered by the body for the last 3 seconds ከተባላችሁ ደግሞ a3 ብቻ ሰርታችሁ ማስቀመጥ ነው የሚሆነው ማለት ነው። a3 ብቻ ሰርታችሁ ማስቀመጥ ነው። So now for the first 2 seconds a1 plus a2 ስለዚህ a1 plus a2 where a1 is the same as length times width is አይደለ? length times width plus a2 which is a right angle triangle which is the same as 1 over 2 base times what? height አይደለ እንዴ? ስለዚህ the distance covered by the body a1 length times width is length 2 ሲባዛ በ3 ከዚህ እስከዚህ ያለው 3 2 times 3 plus 1 over 2 the base of a right angle triangle ከዚህ እስከዚህ ስንት ነው? 2 height ከዚህ እስከዚህ 2 ሲባዛ already the height of a right angle triangle here is that ከዚህ እስከዚህ which is 7 minus 3 which is 4 አይደል እንዴ? ከዚህ ከዚህኛው 4 ስለምትሆንልን 4 ትሆንልናለች which is the same as 6 plus 4 times 2 which is 8 divided by 2 which is 4. So the distance covered by a motorcycle for the first 2 seconds is the same as 10 meter. ስለዚህ በመጀመሪያዎቹ 2 ሰከንዶች 10 ሜትር ያህል ከቨር አድርጓል ማለት ነው። 10 ሜትር ያህል ከቨር አድርጓል ማለት ነው። ዲ ላይ ስንመጣ in which interval of time the motion of a motorcycle is uniform and uniformly accelerated motion. እዚህ ጋር ስንመጣ for the first 2 seconds as the velocity increases the time taken also increase. So there is what? Acceleration, uniformly accelerated motion for the first 2 seconds አይደል እንዴ? ስለዚህ in which interval of time ነው ዩኒፎርም የሆነው? in which interval of time uniformly accelerated motion ስለተባላችሁ አሁን ከዚህ ስንመጣ ደግሞ already velocity constant ነው አይደል እንዴ? so the motions of a motorcycle is uniform motion. ስለዚህ uniform motion ላይ between 2 and 5 seconds ሰከንዶች ከ2 እስከ 5 ባሉ ሰከንዶች already the motions of a motorcycle is uniform motion and in the case of uniformly accelerated motion between 0 up to 2 seconds ከ0 እስከ 2 ሰከንድ ባለው ታይም ኢንተርቫል the motions of a motorcycle is uniformly accelerated motion ብለን አይደንቲፋይ ማድረግ እንችላለን። So this is all the time what we have for today. መልካም ጊዜ